All right, so this is 7.1 to 7.3 review questions. All right, if I have to use a calculator, I'm going to do that off screen. Hopefully you know how to use a calculator. But here we go. So integral from 0 to 14 e to the x over 7. Well, personally, I could do this without the u substitution, but let's show it properly. And while I'm here, u of 14 equals 2, u of 0 equals 0. Substitute everything in. Throw the 7 out front. Seven times e to the second minus e to the 0 equals 7 e squared minus 7. And you can also factor that and write it as 7 e squared minus 1. Both answers are valid. All right, let's do number 2 here. And I'm going to move things up a little higher every now and then to make it easier. You look at this problem, you're immediately thinking of u substitution. Well, u is this, and then I can divide that. This is a great example of a problem that used to give me fits because I didn't see it coming. Just write it in 2 pieces. So 2x squared over x minus x to the 1/2 over x, which is 2x minus x to the negative 1/2. Very weird. The x, which would get you x squared, because it goes over 2. Well, I'll do it all. Cancel, cancel. Minus add 1, x to the 1/2, divide by 1/2. It's like multiplying times 2 plus c. So equals x squared minus square root of x, 2 square root of x, plus c. And you can leave it as x to the 1/2 if you really want. All right. Now, this one might not seem like an obvious u substitution. Let's just say this is going to be 3t to the negative first, and this is t to the negative second. So, I think I'll try u equals 3 over t, which is 3t to the negative first. Du equals negative 3t to the negative second dt. dt equals du t squared over negative 3. Hopefully I don't lose you when I do that. I divided by negative 3, 2 negative seconds on the bottom, so I throw it up top. Let's change our limits. U of 6 over pi equals 3 over 6 over pi, which is pi over 2. And u of 3 over pi is 3 over 3 over pi, which is pi. So make sure you put them in the right place. 3 over pi becomes pi. 6 over pi becomes pi over 2. That's actually going in the negative direction, so I could flip them if I wanted. I'm not going to bother. There's really no reason to. All right, let's see where it takes us. Sine of u over t squared. dt is du t squared over negative 3. Nice. Whoops, keep the du, of course. Throw the -3 out front. Getting a little messy with space here. I'm going to throw 3 out front. I'm going to flip them because I got a negative to play with, so I might as well. Instead of negative, I'll go with pi over 2 to pi. And that's sine of u du. Negative cosine. Interesting. Of u pi over 2. Cosine of pi is -1, so -1 minus cosine of pi over 2 is 0. Keep the negative up front, so just leave it in there. Get this all the way down to 1. Some of you are probably screaming, what happened to the 3 out front? And by the way, it's not a 3 out front. It's a 1/3 out front. -1/3. So we get 1/3. Complicated stuff, and I'm making a real hash of it, so make sure you know what you're talking about. All right, so what's going on here? No idea. I know the derivative of ln of x is 1 over x. Let's try that. U equals ln of x. Du equals 1 over x dx. Dx equals x du. U of e to the 9th is ln of e to 9th, 9. U of 1 is ln of 1, 0. Sure, whatever. Integral from 0 to 9. U to the 1/2. X is still there. X du, looks like we did it right. Cancel, cancel. Integrate, add 1 to 1/2. U to the 3/2 over 3/2, also known as times 2/3. 0 to 9 equals 2/3. 9 to the 3/2 minus 0 to the 3/2. Square root of 9 is 3 to the 3rd is 27 divided by 3 is 9. We should get 18. Remember, when you're done, you should be checking all these to see if you get the same answer on your calculator with nint. All right, now it could go either way, and literally could go either way, but I like the derivative of sine of x is cosine of x. Hopefully I don't have to deal with the negatives. U equals sine of x, du equals cosine of x dx, dx equals du over cosine of x. U of pi over 4 is root 2 over 2. U of 0 is 0. Nice. Sub it all in. Integral from 0 to root 2 over 2. Cosine of x. U du over cosine of x. Integrate u squared over 2, 0 to root 2 over 2, equals 1/2. Root 2 over 2 squared is 2 over 4. 1/2 minus 0 should get me all the way to 1/4. Okay, now derivative secant is not that, derivative tangent is not that. This looks a little tricky. Oh, wait a minute. I don't have to sub in anything. I just have u equals 3x. Just get that out of the way. It's a indefinite integral, so I don't have to do anything there. So integral of secant u tangent u du over 3 is secant u over 3 plus c. Well, Now we got to plug it back in because we don't have any limits. We've had limits here, here, here. Up here, there wasn't even substitution, all right? So secant of 3x over 3 plus c. Oh, I didn't show any of that on screen. My apologies. So there it is. I'll leave it on screen for you. Still learning my dock camera protocols. Okay. All right, what's going on here? U equals, I don't know. I got a weird idea. Let's see what happens. Du equals 1/2 W over 4 to the negative 1/2 times 1/4 chain rule dW. That's 8. When I flip it up, it'll be 8. And then this is actually on the bottom. I'll flip it up here. Square root of W over 4 du equals dW. If I lose anybody in that step, you just slow down and write it out on a separate sheet of paper. Not my desire to make it too complicated, but we do have to keep things moving. U of 4 pi squared. 4 pi squared, the 4 is canceled, pi squared half, and it's pi. U of pi squared, we get pi over 2. Integral from pi over 2 to pi, cosine of u over u. Now leave it a square root. Let's see what happens. 8 times, nice, equals 8 integral pi over 2 pi cosine of, that's a W. No, that's a U. What am I thinking? That's a U over here. Good. Cosine of U, see how easy it is to get confused. That's just 8 sine of U pi to pi over 2. Sine of pi is 0 minus sine of pi over 2 is 1. So 8, 0 minus 1, negative 8. Wow, that's a lot of work. Just a tremendous amount of work. All right, so this one, pretty straightforward. It's done actually. Finally, an easy one. But nobody sees it because our brains are really wrapped up in other things. That's it. And we could use a calculator, but let's go with a precise answer. Arc tangent 1. However, I do know arc tangent of 1. That's where does tangent equal 1? That's pi over 4. So all right. Challenging math. All right. This sets up nicely, I believe, for U substitution. U equals 4 minus t squared. Du equals negative 2t dt. dt equals du over negative 2. u of 0 equals 4. U of -1 equals 3. -1 squared is 1. 4 minus 1 is 3. Rewrite 3 to 4. T u du, forgot my t, over -2t by -1/2. Move that out front. -1/2 integral 3 to 4 u to the -1/2 du, -1/2. Add 1, divide, that's 2 u to the 1/2, 3 to 4, cancel, cancel, equals -2 minus, I'm distributing my negative right away, plus square root of 3. Mathematicians tend to write the positive part first, even though that is a negative number, but that's fine. All right, here we go again. This isn't going to work. There's nothing I can throw here. Oh, wait, that's right. Arc sign. By the way, I'm cheating. I have my answer key sitting next to me because there's no way I would have remembered that. -1/2, 1/2. Would you ever see this on a test? No. AP test? No. Just so you're aware. Where does sine equal 1/2? Boy, I need a unit circle again. Yeah, right there. Pi over 6. And -1/2. Yeah. So pi over 6 minus -pi over 6. 2 pi over 6 equals pi over 3. All right, here we go. So I get this question, and again, it's just so much review. People say, wait a minute, I am so lost. How are we supposed to do absolute value? And I say, well, what's a definite integral? Definite integral, inside parentheses, we're going to go left 3. No, we go right 3. 1, 2, 3, and I'm going to check my work. I'm pretty sure it does this. 1, 2, 3. Let's see now. If I plug in 0, I get 1, 2, 3. Good. If I plug in 3, I get 0. If I plug in 4, I get 1. Yep, looks like it works. So here's 4. I need this area. Here's 1. I need this area. This point here is 4, 1. This point up here is 1, 2. So I got 2 triangles. I'm going to do them both. I could just slap them together, but I'm not going to. 1/2 base 2 times height 2 plus 1/2 1 times 1. 4 over 2 is 2 plus 1/2, 5 halves. So this problem is put in here to remind you, oh yeah, that's right, definite integral means area under a curve. If I can't do the algebra, I could put it in my calculator, but let's just assume we don't have access to that. Then I've got to go back and graph it. These are all AP tricks, all of them that you need to see. All righty. I believe this is tangent secant squared, cotangent. Yeah, there's going to be a negative in there. U equals 3s. We'll deal with the u. Du equals 3 ds. ds equals du over 3. There's no u because there's no limits. Integral cosecant squared u. ds is over 3. I'll throw the 3 up front. Du. 1/3 negative cotangent u plus c. Negative 1/3 cotangent 3s plus c. By the way, if at this point you're like, I can do that without u substitution, I recommend you do. It's almost a guess and check thing. We just slap this out on the page and say, yep, that worked, and off you go. This looks like a contrived problem, like a math teacher made it. The derivative of 3x minus x squared is 3 minus 2x. If I factor out something here, it might work. So let's actually do that first. 3x minus x squared to the third. And let's take a 2 out, put it out front. 3 minus 2x. I think that should work. U equals 3x minus x squared. Du equals 3 minus 2x. Nice. Dx equals du over 3 minus 2x. 2 integral of u to the third, 3 minus 2x, du over 3 minus 2x. 2 integral u to the third du, 2 u to the fourth over 4 plus c equals 1/2 3x minus x squared plus c. Oh my, to the fourth. That was bad. Hey, it happens. Okay, now I threw this in here to mess with you because people are like, oh, it's an e, so the integral is e to the third to e. This is a constant. E to the 3 times t. It's just a number. There's no substitution, there's nothing. Equals e to the third, 3 minus 2 equals e to the third. A lot of people get pissed off at that. They're like, well, why didn't you tell us that was coming? Yeah, well, no, it's all part of the game. All right, a little integration by parts to finish our day off because we haven't had things hard enough already. U equals x, du equals dx. How did I know this? I'm guessing. dv equals e to the 2x dx. V equals, when I take the derivative, there'd be a 2. I'm guessing it goes on the bottom. Derivative e to the 2x over 2 is e to the 2x over 2 times 2 scan. Yeah, all right, we're good. All right, these two first. We're not use substitutioning anything, so we just leave this. Oh, we're actually doing the first part. X e to the 2x over 2 minus e to the 2x integral over 2 dx 1 to 2. And I would actually do this, but getting ahead of myself. X e to the 2x over 2 minus e to the 2x over 4, 1 to 2. You will see problems like this. They're a colossal pain, and they just take some time to blast through them. So what do we got here? 2 e to the fourth over 2 minus e to the fourth over 4 minus e to the 2 over 2, do not cancel those, minus e to the 2 over 4. All right, 4 e to the fourth minus e to the fourth over 4 is 3 e to the fourth over 4. 2 fourths minus 1/4 is 1/4, and it's minus 1/4. Yep. So there's an answer. You could also do this. Either one is good. All right, almost there. Let's go. Another integration by parts. ln of x, you probably are not realizing it's an integration by parts. That's pure experience on my part. And then, well, which one's which? U equals ln of x, du equals 1 over x dx. dv equals dx, v equals x. Interesting. I left v in my answer key. Very disappointing. Okay, these two. X ln of x minus integral x over x dx. Still a 1 and a root e here, and 1 to root e here, equals x ln of x minus x. That's 1 integral is x, equals square root of e times ln of square root of e, which is ln of e to the 1/2, which is 1/2, minus square root of e, minus ln of 1 is 0, minus 1, equals root e times 1/2 minus 2 over 2, negative root e over 2. Check your algebra if you get lost on that one. Plus 1, and like I said, they like to put it first, or maybe they like to make a common denominator. That sort of thing. Well, that was fun. I don't know if that took me about 20, 25 minutes. That's like a 2 or 3 hour job for a student. That's really challenging stuff. But this is the level you're supposed to get to in BC, and it is pure unadulterated practice. It is really not a matter of, oh, I'm good at this, I stink at this, whatever. It is all about how hard you work. Good luck.